Welcome back, guys. We are back on the Project Pulse dashboard, and I'm going to switch the live case from case 8, Ancillary Services Contract plus Arbitrage, to case 11, 2 hours pure merchant. In the last lesson, we modeled an Ancillary Services Contract under monetization pillar 1 of our case study. In this lesson, we stay with the same 200 megawatt BESS, but we move fully into merchant territory and focus on merchant ancillary services. The goal in this lesson is to understand how these merchant ancillary service revenues are modeled properly in the operations sheet. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build the model alongside me. Link is in the video description below. We have now moved on to monetization pillar 2, which covers the fully merchant structures. In a previous lesson, we already built the merchant arbitrage model structure. Now we are adding the merchant ancillary services overlay and focus on the 2-hour pure merchant case in this lesson. Conceptually, we reserve part of the BESS capacity for ancillary services and let the remainder chase price spreads in the arbitrage stack. All of the relevant inputs are already reflected within the input sheets of our model. Our task in this lesson is to wire those inputs into the operations logic and turn them into cash flows. Now let's jump into the inputs time independent sheet in our checkpoint file and make sure case 11 is active. Here under the merchant ancillary services, you can see that we start right after COD, run for the full 20-year term and reserve 40% of AC nameplate, so 80 megawatts AC for ancillary services. All ancillary products are switched on for this case. And the first ancillary product is regulation up. The battery injects power when frequency drops below the target, so the battery is paid to stand ready and to perform quickly. Regulation down is the opposite direction. You absorb power when frequency is too high. Again, paid for availability and response. Spinning reserve is capacity that stays synchronized to the grid and can ramp up within moments if another unit trips. Non-spinning supplemental reserve is similar to spinning reserve, but from capacity that is not currently online and has a slightly slower response requirement. Fast frequency response are very fast injections, typically within seconds, stabilizing the grid after sudden grid disruptions. And lastly, other ancillary services could be things like voltage support or other local reliability services. The model treats all of these as different products, using the same core logic: reserved megawatt, cleared hours, and a price per megawatt hour. On the inputs time dependent sheet, we get the 2 ingredients that drive merchant ancillary service revenues. First, effective cleared hours, per megawatt per year, for each product. That's how many hours the independent engineer expects the project to clear in each service. And second, price forecast in real US dollars per megawatt hour, 1 curve per ancillary service. Both sets of numbers come from the independent engineer or market forecast provider. So for modeling revenues, we already know everything we need to know. How much capacity is reserved for ancillary services, and for each year, how many hours it clears and at what price. Alright, now we are good to move to the operations sheet where we actually convert these assumptions into cash flows. And what we will do in this lesson is first pull in our prices up here on a real and nominal basis. Then we will determine the applicable capacity relevant for our merchant ancillary services. This is similar to our previous lessons. And once we have price and capacity, what we will also need are our cleared hours, which is our third input. And with these 3 inputs, we will be good to model our merchant ancillary service revenues. Alright, but as always, we will now first start with our flag. And for starting with our flag, we can pick up the flag from the previous lesson. So hit Ctrl C, copy this one, paste it here, Ctrl V, hit F2. And now let's really make sure we get all the references right. The timeline references are correct. However, the switch to turn our merchant ancillary services on and off is further down here in row 217. So let's make sure that you select G217 for our switch. And the other 4 references should be okay. So hit enter, drag this one over, Control R, and make sure that you have selected case 11 so that this case is actually active. And you can see that we now have a flag for 20 years again, which is our full asset life. And then the first input we will focus on here is pulling in our different prices on a real basis, so before inflation. And for that, we'll hop into K201. And the model allows for maximum flexibility. So even though merchant auxiliary services are turned on, we can still turn on and off certain services within that revenue stack. So that allows maximum flexibility. And to enable that flexibility, we have to pick up that switch for our formula. So let's pick up that switch as a very first. So hit F4 1, 2, 3 times to anchor to the column. And then the price curves are within our inputs time dependent sheet, which is why we will use an X lookup again. So type X lookup. Our lookup value is our year, our calendar year. So pick up row 4, 2025. Hit F4 1, 2 times, comma, and our lookup array is in the inputs time dependent sheet. And the prices are right down here. Those are the cleared hours. Prices are in row 112 onward. So let's pick up row 114 from column L to column AT. Hit F4 once to fully anchor that reference, comma, and our regulation up price is right here in row 115 right underneath. So make sure that you select the same width from column L to AT. And then very important, let's hit F4 1, 2, 3 times, because we only want to anchor it to our columns, not to our rows, as we will drag the formula down in our operations sheet. Then comma 0 if not found, and comma match mode is also 0 for an exact match. Close parentheses, hit enter. And before we drag that one over, hit F2 and let's multiply this with our flag that we have already modeled up here. Hit F4 1, 2 times to only anchor it to the row. Hit enter. Let's drag this one over, Control R. And that seems to have worked. Great. And then let's drag this formula down up until row 206. Control D. Drag it over to the right. Control R. And let's see if the anchoring is right. So let's go into year 2029 for our other auxiliary services. Hit F2. You can see all these references are right. So let's check the price, 4.52. And we got the same price here. So that seems to have worked. Let's flip back. And you can already see that the 6 different products pay different prices, and services like regulation up or down, which ensures that our grid has a stable frequency, are paid way better than, say, non-spinning reserve or other auxiliary services. And unfortunately, the BESS cannot qualify for high-priced products at all times of the year, but often that then still allows to qualify for lower paying products. And now that we pulled in the real prices, let's put inflation to work and go into row 209, and that equals our price on a real basis before inflation, and we'll multiply this with an XLOOKUP function again, XLOOKUP. And the lookup value is here coming from our inputs time independent sheet from the dropdown, where we have selected the merchant escalation assumption. So select G209, hit F4 once, because we only have one reference, so we want it to be fully anchored, comma, and as in our previous lessons, we refer to this list up here. Hit F4 once to fully anchor it, and the result vector is right here. And here we hit F4 1, 2 times to only anchor to our rows, comma 0 if not found, and match mode is exact, so also 0. Close parentheses, hit enter. And this time we do not need to multiply with our flag up here because the price on a real basis has already been multiplied with the flag. Hit Ctrl D for these 6 rows and then drag them over, Ctrl R. And you can see that we now have a proper inflation of all price curves, where we always refer to our merchant curve, $15.8 right here, which will be multiplied with 1.18. So 15.8 times 118 is 18.6. Great, now we have the prices that we need for our merchant auxiliary services, and now we need to know our capacity. And this is very similar to our previous lessons as well. So for our reserved capacity, we will first and foremost pick up our reserved factor in H217, hit F4 1, 2, 3 times, and multiply this with our flag. And our flag has already been multiplied with our on and off switch, so no need to pick that one up. Hit F4 1, 2 times, and now we need to scroll up to our power and energy section, and this is the reserved capacity before any adjustments on a megawatt AC basis. So here we multiply with our reserved factor, so now we just need to pick up the gross capacity on a megawatt AC basis. Scroll up and let's find that value. And that will be in row 46, where we are given 200 megawatts AC. So let's pick up K46, hit F4 1, 2 times, enter, drag this one over, Ctrl R. And although we have picked up 200 megawatts, since we multiplied with 40%, our actual reserved capacity for merchant auxiliary services is 80 megawatts. And then similar to our previous lessons, we will also have a nameplate adjustment in case our battery ever breaches nameplate capacities, in case there's an augmentation missed, for instance. So to do this, we will have an if error statement again, because we will divide by 0, if error. And let's scroll up to our energy section. And what we'll do here is pick up our AC deliverable energy cap per cycle, which is our energy after considering any potential breaches. So this takes the minimum of what is contractually required and physically available within the BESS. So let's pick up this row, hit F4 1, 2 times, and you can see that our contractual obligation is delivering 400 megawatt hours on an AC basis. So here we take the minimum of this, but if the battery were to ever physically breach these 400 megawatt hours, then this value here would be below 400, which is why we take this one and divide this with our actual contractual nameplate capacity before any adjustments of physical breaches, which is K59. Hit F4 1, 2 times. And if that's an error, let's return a 0. Close parentheses, hit enter. And let's not forget to also multiply this with our flag up here. So pick up K198, hit enter, and let's drag this one over, Ctrl R. And you can see that stays at 100% because we have in total 2 augmentations scheduled to ensure that we always maintain our minimum nameplate capacity. Then capacity after nameplate adjustment again is the reserve capacity multiplied with the factor. And for the next 2 adjustments, the capacity after availability and curtailment, let's make our lives easy and actually scroll up to our previous section. Let's pick it up from the Ancillary Services contract. And here we can just pick up these 2 formulas, Control C, which we have already modeled plenty of times, Control V, paste them here. And let's check the references. This switch is referred to properly, same here. and let's scroll up. And we refer to our availability factor up here. Let's check the reference for this one. And here we refer to our curtailment factor. Hit enter. And the applicable capacity for merchant ancillary services revenues is again a simple linkage to the last value after all of our adjustments. So once we have those four guys, we can drag them all over, Control R. And you can see that out of the 80 megawatts on an AC basis, after the two adjustments for availability and curtailment, we have approximately 77 megawatts on an AC basis left. So now we have prices and we have our capacity, but one piece is missing, and these are our cleared hours. So this is how much capacity we can provide the service for, and these are the prices that the system operator will pay us. But we do not yet know out of how many hours per year that service will be provided. And that's again an estimate from our independent engineer and something we will pick up from our inputs time dependent sheet. And let's start with the first service, which is regulation up. And that will equal to, let's scroll up, our on and off switch here first. So we only want this to be picked up if the service is on. Anchor it 1, 2, 3 times with a 4. Then we also want to multiply this with our flag. Hit F4 1, 2 times. And then, as always, let's multiply it with an X lookup. And the lookup value is again our calendar year in row 4. So select K4 and hit F4 1, 2 times, comma. And let's hop over to our inputs time dependent sheet. And here we have cleared hours for 2 different products. We have merchant auxiliary service forecast for a 1-hour BESS selection and a 2-hour BESS selection. And you can see that our live case right now selects the 2-hour BESS, which is a dropdown in the inputs time independent sheet, and should always align with the actual product that the case is assuming. So you can see here are 2 hard-coded values, and then the live case is selected in case 77. And for modeling purposes in the operations sheet, we make our life easy and have a summary of all live cases right down here. So this is what we will pick up. We will pick up row 104 for the years, from L104 to AT104, hit a 4 once. And our return array is for the first product, row 105. Make sure you select column L105 up to AT105 and hit F4 1, 2, 3 times. Comma 0 if not found, and match mode is again exact match 0. Close parentheses, hit enter. Let's drag this one down, Control D, drag it over, Control R. And this to me looks like the same hours we have assumed in our inputs time dependent sheet. So we get 2005 for 2027 and 92 on the bottom one. And this seems to align. That's great. And now we're almost done with this lesson. All we have to do is calculate our revenues now and then sum them all up. And let's start with our regulation up revenue. And open parentheses. We will start with our price in nominal terms. So after inflation, that would be K209. Multiply this with our applicable capacity for merchant auxiliary services revenues, which is K222. Let's anchor this to the row only, so hit F4 1, 2 times. And then we'll multiply this with our hours that we just pulled in, which is row 225. And we don't need any anchoring for the price and hours, because these two references will move down and to the right as we drag the formula over. Let's close parentheses. And now watch out, our prices again are given in US dollars per megawatt hour. However, right here, the output is given in thousands USD. So we will have to divide this whole multiplication by 1,000. So just type in 1,000, hit enter. Let's copy this, Alt HVSF, so we don't mess up our formatting. And let's drag this one over, Control R. So that's great. Let's actually move up, and we have missed something here, which is our row sums. So we can pick up these two guys here, copy this, paste it here, and let's copy this guy and paste it 5 times here. And then we're good to take the sum of all of these 6 different revenue streams, drag it over, Control R. And you can see that reserving 40% of capacity for merchant ancillary services would lead to roughly 239 million in revenue through 6 different products. But as you can see, the majority of revenue comes from the regulation up and down service. And that's the service that maintains grid frequency at the target value of, say, 50 or 60 hertz, which is something we have learned in a previous lesson. And 40% of the battery generating this revenue stands against 60% generating 225 million in arbitrage profit. So we can see that reserving less than half of the capacity actually leads to more revenue than we generate with arbitrage, where we have to give up 60% of our BESS capacity. So merchant auxiliary services can really pay off, assuming the independent engineers' forecasts are correct. And in our next lesson, we will add a revenue put option on top of this structure. You can think of a revenue put option as an insurance product that sets a revenue floor, which is exactly the kind of feature lenders like to see when you're financing merchant heavy or fully merchant projects. Alright guys, this was it for this lesson, and I will see you in the next lesson. See you there.